Welcome to Unit 1, Lesson 3. Hopefully, by the end of this day, you will be able to fit a function to a data set and use the fitted function to answer questions. Most of this is going to be, this lesson is kind of, it's 50-50, calculator driven, where we're going to input our data set on a calculator and we're going to plot the points, and then we're going to see what type of function will fit it, whether it's linear, quadratic, and we'll talk later on about exponential. Usually these go together, but we're going to come back to that, to the exponential functions, but we're going to focus today on linear and quadratic. But since we don't have calculators at home, we're going to focus today on distinguishing from our data set what type of function it can be. We can actually look at a set of numbers and get a feel for whether or not that set of numbers represents a line, quadratic, or a exponential function. But today we're just, like I said, focusing on linear and quadratic. There we go. I wrote that out for you. So distinguish what type of function my data set represents. That's kind of our goal for today, and which is related to our ultimate goal for this lesson. All right, so I hope you were able to write both of these down, because anything I write should be in your notes, right? And if they're not there, what's going to happen tomorrow morning? That's right, you're going to get a jug. So this is your warning now. I want to see complete notes with all your work and effort, okay? There should be no one who doesn't do this. All right. Think about it. All right. So, do you remember what a linear graph looks like? All right. Linear means what? Linear means line. So, I want you to sketch the graph of a line. Sketch the graph of a quadratic. Now, exponentials, you don't know what an exponential looks like. So, I'm going to give you a little graph of an exponential. Okay. So let's do that. All right, so let's put our exponential function on there. Don't forget to label your axes, guys, right? So I have my x-axis, right? And then I have my y-axis. Okay, we're not going to put values on that right now. This is just a sketch for you to kind of see what it looks like. So this is part of my intro to exponentials for you. Its graph looks like that. And we'll talk about the key characteristics of each one of these, right, if they have them, right? So what did we say our key characteristics were before? I believe we said they were the y-intercepts, right? Y-intercept. The zeros, right? And those are equal to what again? Those were equal to our x-intercepts, right? A vertex, if it has one. And then there are some other things that we would consider key characteristics for different functions, but really this is kind of what we're looking at, all right? And does it have a maximum or a minimum? Does it have a max or min? What do you think? This is a little bit of analysis here going on now. Tell me if it does, and what is it, okay? And we'll talk. Remind me in class, and we'll talk about domain and range for these functions really quick, okay? So in your notes, I should see domain question mark and range question mark, and we'll pick this up tomorrow, all right? So I want you to find all those values if they have one, and I want you to sketch a graph of each one of them, what the function looks like, Okay? So there's a spot for you to sketch, and there's a spot for you to write what the key characteristics are, what they're equal to in the general case. Okay? Now, all right, given a set of data, how can I tell if the data represents a line or a quadratic function? Well, put simply, if the difference in the y values, the output, which should be one word, not two, sorry about that, guys, we'll pretend that's one word, of my function are all the same, then my set of data can be represented as a linear function. So that means if I subtract consecutive y values, that my difference is the same. It means I get the same number every time I subtract. All right? If the value is the same, then it's a linear function. If the difference in the differences, if the difference in the difference of the y values are all the same, then the set of the data can be represented as a quadratic function. Sometimes you may have to do the difference of the difference of the difference, which means you're subtracting them. You're subtracting consecutive y values multiple times. All right? If you do this 5 times and they don't match, well, guess what? Then it's not a quadratic. All right? And as a matter of fact, usually after the first time, if they don't match, it's not a quadratic. On a very rare occasion, you'll have to do it 3 times. All right? So take a minute, pause the video, write this down. Okay, so I hope you wrote down these rules for finding them, and we're going to apply them now. All right? So does the data represent a linear function, a quadratic function, or neither? So for those rules, it said to subtract the difference, right? So let's look at the first difference. So that means I'm going to subtract 1/2 and 1. And what am I going to get? I get, what's the difference? Sorry, what's the difference here? The difference is 1/2. The difference between 1 and 2 is 1. The difference between 2 and 4 is 2. The difference between 4 and 8 is 4. Then 8. Then 16. Okay, so now I look at the differences. Are they the same? No, they're not the same. So is it linear? Absolutely not linear. Okay? So now let's look at the difference again. So 1/2 and 1 is going to give me 1/2. Then I get 1, 2, 4, and then I get 8. Do it again. 1/2, 1, 2, 4. Are the differences the same? No. Is this quadratic? No. So this one is neither. All right, did you get the idea here, guys? So here's the first difference. Here's the second difference, if you can see it very well. All right? It's kind of hard to see. Sorry about that, guys. So let's erase this, and let's look at another one real quick. All right, let's look at number 3 here. First difference. I get 9. Second 7, 5. Sorry. 3, 1, and 1. Okay, let's look at the second difference. I get 2, 2, 2, 2. And we're going to ignore the last one because we would call that an outlier. So based on our data that we have, this function here that represents these values could be, and most likely is, a quadratic. All right? So we've done one that's neither quadratic, and we've done one that's the one that's neither quadratic nor linear, and we have done one that's quadratic. I'd like you to finish up the rest, guys, on your own as part of your homework, okay? and I will see you in class, and I should see work for every single one of these where you find the differences. Every single one. Nobody should come in with no homework. All right? Have a good night, guys, and I will see you on the next day, whatever that is.